Chapter 8.4, Day 1, we're looking at the determinant of a square matrix. So we're going to find the determinants of matrices, find minors and cofactors of square matrices. Then later on, we'll find determinants of square matrices. The determinant of a 2 by 2 matrix, now we found this in a previous lesson. Each square matrix can be associated with a real number called its determinant. Determinants have many uses, and several will be discussed in this section and the next. Historically, the use of determinants arose from special number patterns that occur when systems of linear equations are solved. For example, this system here has these solutions. Note that the denominators of the two fractions are the same. This denominator is called the determinant of the coefficient matrix of the system. So looking at these numbers here, we have A equals, and we labeled this a little different the last time. We had A, B, C, and D, but now we're labeling it as A1, B1, A2, B2. So A1 for the first equation, A2 for the second equation. So that'll help us a little bit later on. And so the determinant is you multiply A1 and B2, and then subtracting the A2 minus A2 times B1. So the determinant of the matrix is this. It's given by this formula, which we just talked about. So what we're going to do is go ahead and find the determinant of each matrix. You could probably do these on your own, but we can do it together. So we can get different values. So for example, in this one, 2 times 2 is 4 minus 1 times negative 3. So that is actually going to be a 4 plus 3, which is 7. Here we get 2 times 2 minus 4 times 1, which is 4 minus 4. So our determinant is 0. Then here we get 0, and then minus 2 times 3 halves, and notice our answer is negative 3. So it's possible to have positive values, negative values, as well as zeros. So try out A, B, and C here. So trying this out, you should have gotten negative 7, and letter B, that is 10, and then letter C, that is 0. So the first one is negative 1 minus 6, so it gets you the determinant of negative 7. Letter B is 10 minus 0, so the determinant is 10. And letter C, that's 12 minus 12, which is 0. Now the determinant of a matrix of dimension 1 by 1, it's simply defined as the entry of the matrix. For example, if the matrix is negative 2, then the determinant is just negative 2. Now let's take a look at minors and cofactors. So here is the formula here, Cij equals, and then negative 1 raised to the I plus j, and then times Mij. So m is the minor, and then we're going to use that to help us with our cofactor. Now here is just a little bit of information. Here's some sign pattern for cofactors, so we'll use that in a little bit. So notice it's positive here, positive, 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 and then the other values are negative. And notice that it alternates. Okay, so there's a pattern to it. Now in the sign pattern for cofactors below, or above actually, above, notice that the odd positions where I plus j is odd. So remember, I represents the row, j represents the column. So where I and j is odd, when you add it together, then it has negative signs, and then it's even when I and j are even. So remember, like for example here, if we're looking at this first position here, this is Aij, so this is the first row, A1, first column. And so when we add the I and j, that is 2. So let's do this one. This is row 1, column 2, so that's A, that is 3. Okay, and that's so we're looking at 3, 2, so this is even, this is odd, and then you see this one's going to be 4, which is even. So that's what it's saying. So odd positions, I plus j is negative, and then I plus j, when you add those together and it's even, then they have positive signs, and that may be quite helpful. So let's find minors and cofactors of a matrix. So to find the minor, what you're going to do is you're going to delete the first row. So if we're trying to find M11, the minor M11, we delete the first row, we're trying to find this, and then we delete the first column. Then what you do is find the determinant of the resulting matrix. So for example, M11, this is negative 1 minus 0, so therefore it is -1. Then to find M12, so we erase everything here, then we are looking at deleting, so finding this one, we delete this row and this column, and then finding the determinant of the resulting matrix, so the matrix is 3, 2, 4, 1, then this is going to be 3 minus 6, or 3 minus 8, sorry, 3 minus 8, and so this is -5. And then you keep on doing that to find the rest. You find M13, so you continue that same process to find the rest. So M13, delete this and this, and so it is 0 minus a -4, which is a +4. Then let's do the next row, M21. So this is going to be, we're trying to find this, so you delete this row, delete this column. So what you're left with is the determinant, which is 2 minus 0, so it's just 2. Then you do the next one, M22. And I'm sure you're seeing the pattern now. And so see if you can go ahead and finish this out. You just keep on continuing until you find all of the minors. So hopefully you found the rest. So M21 is 2, M22 is -4, M23 is -8, M31 is 5, M32 is -3, and M33 is -6. So next what we need to find are cofactors. So in order to look at the cofactors, we can look at the pattern, the sign pattern for that. So let's find cofactors. And we're going to find it for each one. So this is C11, and I'm just going to write it C12, C13, C21, C22, C23, and then C31, C32, and C33. So if we look at the pattern for now, we notice that it's positive, that it alternates, positive, negative, positive, negative, positive, and so forth. So there's a pattern to that. So what I'm going to do is I'm just going to go ahead and take all the positives, so meaning I'm going to take these here and write them, because I know it's just the same. So this is -1, 4, -4, 5, and -6. Then I'm going to take these are going to be the negative signs. I'm going to change the sign to the opposite sign. So this is 5, this is 2, this is -8, and C32 will be a +3. Oh, this should be a -2, -2, -8, and +3. So here are all the cofactors, and that's going to come into play a little bit later. So that's one way to find it. Again, just to reiterate, notice when you add 1 plus 1, that is even, so therefore it stays the same sign. 1 plus 2 is odd, therefore we have the opposite sign. And then 1, 3 is even, so then it is the same sign. Okay? So try out finding all the minors of cofactors of this example here. All right, trying this out. So first, finding the minors. So the first row is -9, -10, and 2, 5, -2, and -3, and 13, 5, and -1. Then the cofactors, you just change the signs. So this is -9, +10, 2, -5, -2, 3, 13, -5, and -1.